Despite what some certain science fiction works may deceive you into believing, habitable planetary mass bodies of Earth-like temperatures generally are unlikely to have only a single biome on their surface. Briskillanya, being an extraordinarily Earth-like world, has roughly the same variety of climate types on its surface as Earth. This episode is about Briskillanya's physical geography. I originally intended for this to be a single video, but it became far too long, even though I did say last time that this video was to be a short one, so it will be a two-parter. Since it is a smaller planet than Earth, you may expect Briskillanya to be significantly less geologically active than Earth, but as you may expect from me saying you may expect, this is not true. This is because Briskillanya's interior is more rich in heavy radioactive heat-producing elements, especially thorium and uranium, than Earth's interior, a consequence of Briskillanya having a proportionally larger iron core. Therefore, Briskillanya has all the geological processes and features you would expect from an Earth-like world, such as plate tectonics, volcanism, a magnetosphere, and erosion. As a brief aside, Lausanne, Haristi, Wheatley's, and Sierra Red do not have most of these activities because they're small to the point that their interiors cooled off in the distant past, while Soteria is a fairly active planet in terms of volcanism, but mostly tectonically inactive, because a collision in its early history turned it into a slow rotator, a slowtator if you will, which made the planet lack a sizable magnetic field, which made it lack water, and oceans are important for the formation of plate tectonics. Finally, Aranov is internally similar to Briskillanya and is more geologically active, having frequent volcanism, extreme seasons, and plate tectonics. There are a few areas on Briskillanya's surface that generally have high levels of volcanism, like the Rasilia Bay, Eastern Echin, the Roghian Coast, the Central Cedini Mountains, most of Hiyentia's western coast, Central Helara, Bache, and northern Aberkeen's western coast. When Briskillanya's recent ice age ended, the receding glaciers created countless tiny lakes all over the planet. Briskillanya is generally cooler than Earth, on average being 12.7 degrees Celsius in temperature, as compared to Earth's 14.9 degrees Celsius. This is because Briskillanya is orbiting a marginally dimmer star at a marginally greater distance, but this cooling is offset by Briskillanya's marginally greater greenhouse effect, giving the planet its rather comfortable temperature. Briskillanya's seasons and the transitions between them are milder than Earth's due to its smaller axial tilt of 15 degrees, as opposed to Earth's 23.5 degrees. In some parts of the planet, in fact, most notably the temperate parts lying close to the tropics, the seasons are so subtle that many people living there in prehistoric times did not even realize that there were seasons until people from places with more extreme seasons pointed their existences out. The smaller obliquity also causes the planet's tropical and polar zones to both be smaller, and for the planet to be slightly cooler, as the mildness of the summers prevents the ice caps from suffering too much seasonal melting. The perennial persistence of the polar parts makes Briskillanya more reflective, so more of Mirabilisk radiation is reflected back into space, creating some of the aforementioned cooling effect. Due to its Earth-like rotational period, Briskillanya's wind currents look like Earth's, and its ocean currents can be derived from this. Using this and the location of the highlands, here is a map of Briskillanya's climate zones. I will not explain in detail what forms all these zones, as you can learn elsewhere, but the gist is that land near warm ocean currents is typically more humid, land near cool ocean currents is typically more dry. Equatorial zones are, of course, warmer than the temperate zones, which are in turn warmer than the poles, and mountains keep areas upwind of them wetter and areas downwind of them drier. This is called the rain shower effect. Finally, the higher an area's altitude is, the lower its temperature is. If you compare this map to Earth's climate map, you can see that Briskillanya's tropical climate zones are squeezed equatorward, and this is because of the planet's lower obliquity and cooler temperature. The temperate climates are very broad because of all the extra room, and the polar climates are roughly the same size. A region's climate has a very large impact on what that place is like, as it affects population patterns, what the people there eat and how they get it, how easy it is to create infrastructure there, how other regions would interact with that region, etc. I will take this opportunity to say that I took some artistic license while making this map. The Paidini and Central Deserts are probably pretty unrealistic and probably wouldn't have existed if I had designed Briskillanya today, and I'm unsure whether cool, low obliquity planets actually look like this. However, I'm happy with how this map looks. Because this map uses some dense jargon, I'll explain what each of these climate zones are. Of note before I start is that the dark gray parts scattered all across the map represent highlands, which are not categorized here. The first climate zones I'll mention are the tropical ones. First of the tropical climates are the tropical rainforests, which are what they sound like. All year round they are very humid, rainy, and hot, and have dense forestation, like Earth's Amazon and Congo rainforest and most of Indonesia. Tropical monsoon climates are also hot, but have intense wet and dry seasons like the western coast of India. Tropical savanna climates are hot, lightly forested grasslands that are usually rather dry, but do have rain in their summers, like much of the central parts of Africa. Hot steppes are semi-arid, nearly treeless grasslands that act mainly as a transition between the tropical savannas and hot deserts, like the Sahel. Hot deserts are very hot at day, and arid regions typically lacking much vegetation, instead being sandy and rocky, and are like Earth's Sahara, Outback, and Arabian deserts. Poleward, there are the temperate climates, starting with a humid continental climate, which can be thought of as the default temperate climate. They have 4 comparably extreme seasons, like the northeast United States, Central and Eastern Europe, and northern Japan. Cold deserts are arid places that can get warm in the summer days, but are usually rather cold, like the Gobi Desert or Patagonia. There are slightly less arid versions for the cold steppes, unforested grasslands/shrublands that see little rainfall and can be colder than the cold deserts, like much of the western United States or the Eurasian steppe. A Mediterranean climate experiences hot, dry summers and temperate, wetter winters like, believe it or not, the Mediterranean coast and the US's Pacific coast. Humid subtropical climates, on the other hand, have subtle seasons for a temperate climate, and are hot or at least warm as well as humid and rainy year-round, like the southeastern parts of the United States and China, or the Rio de Plata Basin. The oceanic climate has rather cool to moderate weather, except in the slightly warm summers, and is rainy all year, like Vancouver, New Zealand, Tasmania, southern Chile, the British Isles, and a big chunk of Western Europe. Finally, there is the coldest temperate climate, the subarctic one, which has cool summers and very cold, dry winters, and often takes the form of boreal forest, much like Siberia, most of Canada, and Fennoscania. There are 2 more climates after that, the 2 polar ones. The first is the tundra, which is very cold for the whole year and has little life, like the Arctic coast. Finally, there's the coldest climate of all, the ice cap, which is permanently covered in ice at the extreme cold, like most of Greenland and Antarctica. As a final note in this section, I'll point out that no climate zone is homogeneous. The climates that I have described are generalizations, and a fair deal of climatic diversity exists within each climate zone, especially where they border other zones. Hiyentia is a very tall and skinny continent, as well as a relatively flat one. It is so flat because the Hiyentian plate has not strongly interacted with any other plates in a long time, except in the west, where the eastern Nehesho plate is currently moving underneath Hiyentia, volcanically creating the mountains you see here. Due to the continent's flat nature, Hiyentia is warmer than areas of similar latitude on Aberdeen, and its coastal climates extend a large amount inland, as there are fewer obstacles for wind and clouds. Because of the topography, it was historically easy for people to travel from west to east and vice versa, but not so much for them to do so north to south and vice versa because of Hiyentia's latitudinal range. Hiyentia's shape gives Briskillanya's second smallest continent a great diversity of climate zones in a comparably small area, and the differences in climate zones have historically complicated north to south movement. It also gives an explanation for the region's population patterns. Haldaris primarily live around the center of their country, between the cold and densely forested subarctic climate and northern oceanic climate to the north, and the hot steppes, deserts, and expansionist neighbors to the south. Haldar's capital and largest city, Toralbar, is located here in the oceanic climate southern parts, giving it a comfortable temperature and a lot of precipitation. Haldar's very flat southern desert, the Rodbar Desert, historically served as a barrier between Haldar and the rest of Hiyentia, keeping it culturally independent and safe from invasion. Haldar's southwestern hot steppes and savanna was historically part of Yeneth before the region was invaded and annexed by Haldar. And Yenton is a very climatically diverse country, even ignoring its Halaran part. Most Inyentonians live in the country's very warm savanna-dominated northeast, between the 2 deserts and east of the Kees Mountains, which served as a historical barrier between Inyenton and Yeneth. Inyenton's capital, Inyent, is located in the tropical savannas. The rainforest surrounding Lake Boundary used to be diffusely populated by humans due to the thick tree cover, but large amounts of logging have allowed the region to become more densely inhabited. To the south is another more topographically rugged desert, the Ainthair one, that separated the northern Hiyentian cultures from the southern Hiyentian ones, like the Mediterranean Jia and subtropical Traja, and the mostly oceanic southern Senili tribes. These parts of Inyenton are much less densely populated than what is often called Inyenton proper. Helara is the smallest Briskillanyan continent, as well as the coldest one on average, due to its poleward location. It is partially a mountainous continent because the Rochian and Kaunjar plates both recently started sliding underneath Helara. The northern warmer regions, as in the humid continental and oceanic climates, are where most people live, including both Indiantonian colonists and Verokakhians. Verokak's coastal capital, Kakhina, is located in the oceanic portion. The Hiyenian people are native to and generally limited to the continent's southern parts, like the subarctic and tundra climates, a factor responsible for the Hiyenian region's generally tiny population density. This south is close enough to the planet's southern ice cap to actually touch it in the colder herrings. Helara's mountains create small amounts of arid land, and the Meso range of mountains facilitated the splitting of Verokakhian and Hiyenian culture. I will cut this episode off there. Abrakeen and Paidean will be discussed in part 2. Just to clarify, both of these videos are to be considered as parts of episode 10 because they're very similar. I feel that episodes 7 and 8 are distinct enough to get separate episode numbers, but that doesn't apply here. Goodbye.